welcome back to my YouTube channel, Massa Tutorials. Please do well to subscribe to this channel. Alright, thank you. Today we'll be taking this topic still on Math 102 Analytic Geometry and Calculus. So still we'll be doing point of intersection of two lines. Point of intersection of two lines. Point of intersection of two lines. So now, let's see. To find the point of intersection of two lines, solve the equation of the line simultaneously by any preferred method unless what stated. The solution set is the point of intersection of the lines. Now, to solve for the point of intersection, when two lines meet at a particular point and you want to find for the point of intersection, or you want to find for the coordinates of the point of intersection, you have to solve the two lines obtained simultaneously. Now, we have methods in solving the simultaneous equations. We have the elimination method, the substitution method, the graphical method. Then you can use the matrix method approach. You can use the Cramer's rule or the inverse approach. Alright, so now let's see. Example 1. Find the points of intersection. Find the points of intersection of the lines. 2x minus 3y equals 6 and 4x plus y equals 19. So how do we find for the points of intersection of these two lines? How can we calculate for the coordinates of the points of these two lines? So now with this we have to solve the two lines simultaneously. So we have the line L1, then we have the line L2. So how can we solve it simultaneously? Now you can use the elimination method. So now using the elimination method to solve the two lines simultaneously. So how can we use the elimination method? Now, to use the elimination method, now elimination means to get rid of a variable. So now here we are getting rid of the variable y. We are getting rid of the variable y. We want the variable y to go to 0. So how can we let this variable y go to 0? Now, if you want a variable that's y to go to 0, make sure that in equation 1, the variable y, the coefficient of the variable y in equation 1 is the same as or is equal to the coefficient of the variable y in equation 2. So now let's see. In equation 1, the variable y here is -3, right? Then here in equation 2, the variable y is +1. So how can we let these two variables, the coefficient of these two variables y, be the same? So now what we can do here is you can choose to multiply equation 2 by 3. Multiply equation 2 by 3, so that I get here. You forget about the sign for this one. Forget about the sign here. Then let's concentrate on the value, the coefficient, the number here, which is 3. So now here, which is 1. So now we can choose to multiply equation 2 by what? By 3. So now let's go. So I'm multiplying, or we are multiplying equation 2 by what? By 3. So now 3 times 4x gives what? 12x, right? Then 3 times y gives 3y. Then which must be equal to 3 times 19, 3, 9, 27. Then 3 times 1 is 3. Then plus 2, which is what? 57, right? So now we can label this one as equation 3. Then now we have our old equation 1, which is what? 2x minus 3y equals 6. So now here we go. We cannot eliminate the variable y. We can eliminate the variable y. How can we do this? Now, let's check the signs in equation 1 and equation 2 for that variable what? Y. Now, the sign in equation 1 is what? Plus. And the sign in equation 3 is plus. And the sign in equation 1 is minus. Now, how can we eliminate the variable y? This time around, the variable y, their signs are not the same. They are what? Different. They are not the same. They are different. So we have plus then minus. Now, if I want this variable y to go to 0, then I have to add the two equations. We have to add the two what? Equations. So we are adding both equations. That's I'm adding equation 3 to what? Equation 1. So 12x plus 2x gives what? 12x plus 2x gives what? 14x, right? All right. Let's continue. Then we have plus positive 3y, then negative 3y. When we add them, we get what? 0. So now we can say that they are gone, which must be equal to 57 plus 6. 7 plus 6 gives what? 13, right? So we write 3, then carry 1, which is what? 63, right here. Alright, so now we want what? We want the coefficient of x. We want the value of what? X. So we have to divide both sides by the coefficient of x, which is what? 14. So now here, 14x on 14, which must be equal to what? 63 on what? 14. So x must be equal to, which is 9 on 2. 9 on 2. So now we can label this one as equation what? 4. We can label that as equation 4. Then now we know the value of x, which is what? 9 on 2. So we can substitute x equals 9 on 2, which is what? Equation 4 into either equation 1, 2, or 3. Any preferred equation. So now here, I can go ahead and say that put equation 4 into equation 1. So equation 1, we have 2x minus 3y equals what? 6. So 2x minus 3y equals 6. Right. Then we substitute the value of x, which is what? 9 on 2. So now 2 times. So I have 2 times 9 on 2 minus 3y equals what? 6. Now this guy cancels that guy. So I have what? 9 minus 3y equals what? 6, right? So we group like terms. So 9 minus 6 equals 3y, right? 9 minus 6 gives what? 3 equals 3y. Then we can divide here by 3 also by 3. So y equals what? 1. Y equals 1. So now let's testify using our calculator. Let's see. Alright, so that's correct. So we have what? X being equal to what? 9 on 2, then Y being equal to what? 1. So now they said we should find the point of intersection of the lines. So now, since we had X to be 9 on 2, then Y to be what? 1. So we know that the coordinates of the point is in the form XY or AB. So our X is 9 on 2, then our Y is what? 1. So we can say that therefore the coordinates of the point of intersection is what? 9 on 2 what? 1. 9 on 2 what? 1. So that's that. So that's that. You can watch it carefully. Alright, so let's see next example. Let's see next example. To find the point of intersection of the lines 3x plus 2y equals 2, right? And 4x plus 3y equals 7, right? So how can we find for the point of intersection of these two lines? So now, still you have to solve the two lines simultaneously. You have to solve the two lines simultaneously. Now, we can use the matrix approach here. We can use the matrix approach to solve the simultaneous equation. It is possible. So now, you can choose to use the Cramer's rule or the inverse approach. Now, let's use the Cramer's rule. So, using the Cramer's rule. So using the Cramer's rule to find for the value of what? X and Y. Now, to find for the value of X, the Cramer's rules method states that what? We have to find for what? The determinant of AX, right? All on the determinant of A, right? The matrix we will deduce from these two equations will be what? Our matrix A. The matrix we will deduce from this equation 1, then equation 2 will be what? Our matrix A. So that's why I said what? X must be equal to what? The determinant of AX all on what? The determinant of A. Then Y, to find for the value of Y is the determinant of AY all on the determinant of what? A. Right. So now let's see. We have 3x plus 2y equals 2. Then, which is equation 1, then we have 4x plus 3y equals 7, which is equation 2. So now, let's deduce our matrix. So we have 3, 4. We are just writing their coefficients. Then we have 2, 3, right? Multiplying what? X, y, which must be equal to what? 2, 7. So this one. In matrix form. So this one is a square matrix. That's a 2 by 2 matrix. Then this one, a column matrix, right? So that's a 2 by 1. 2 by 1. Then this one too is a column matrix, right? A column matrix. That's 2 by what? 1 matrix. So when you multiply a 2 by 2 matrix by a 2 by 1 matrix, you obtain what? A 2 by 2. So you get your results as that, which must be equal to what? This 2, 7, right? So now, we can say that so that's it. Let A be equal to what? 3, 4, then 2, 3. 3, 4, then 2, 3. Now, we have to find for what? The determinant of that. The determinant is a value. We are obtaining a single value. We are obtaining a single value here. So we have to find for the determinant of this matrix what? A. So how can we find for the determinant? So the determinant, which is that 2 bars, right? So now, the 2 bars is the determinant of A. Then we do something like that. So 3, 4, then 2, 3. It means we are finding for the determinant of this matrix. Now, how do we find for the determinant? That's our first diagonal. We multiply our first diagonal here. So the determinant of A must be equal to what? We multiply 3 times 3. Then we subtract, so minus what? The second diagonal, which is 4 times what? 2. So the determinant of A must be equal to 3 times 3, we have 9. Then minus 4 times 2, we have 8. Which will obtain the determinant of A to be equal to what? 1. So that's our determinant of A. So we have our determinant of A to be equal to what? 1. So watch it very carefully. Alright, so now we can proceed and say that we can find for what? Now we know our determinant of A, right? So we can find for our determinant of AX. How can we find for the determinant of AX? Now let's see, let's obtain AX first. To obtain AX, watch here. We have our matrix A, which is 3, 4, 2, 3, right? In a column form, that's 3, 4, 2, 3, right? So how can we obtain AX? Now, the whole of this column here, the first column here, they are the X values, right? And the second column here, they are the what? Y values here. So the first column are what? The X values, and the Y. The first column are the what? X values. Then the second column are the what? Y values. So now here, we want to find what? AX. So we take away this first column, which are what? The X values, because it is what? Demanding for AX. So we eliminate this 3, 4. We take away this 3, 4. Then we substitute 2, 7 in place of that. So 3, 4, I'll write what? 2, 7. So in place of this 3, 4, I just substitute 2, 7. Then I have what? 2, 3. You still write your 2, 3. Don't touch the Y values. We are dealing with what? X. So you touch what? The X values, right? So now here, then we can find for the determinant of AX. Now, so the determinant of AX, which is 2, 7, then 2, 3. So how do we find for the determinant of AX? To find for the determinant of AX, I told you to multiply the first diagonal. So we have to multiply the first diagonal, then minus the multiplication of the second diagonal. So I have the determinant of AX must be equal to 2, 3, 6, 7 to 14. So we have 6 minus 14, which gives us what? 8. Right, sorry. That's negative what? 8. Negative 8. That's negative 8. 6 minus 14 gives us what? Negative 8. So now, this is our determinant of what? AX. Our determinant of AX. So kindly watch it carefully. Alright, so let's proceed and find for our determinant of AY. What will be our determinant of AY here? Our determinant of AY, we have to first locate our matrix AY. Our matrix AY. Now, the same thing we did for what? Matrix AX. But this time around, we are concentrating on the Y what value. So now we eliminate this 2, 3. We eliminate this 2, 3, or we take away this 2, 3, then we substitute 2, 7. Now, don't still write 2, 7, then 2, 7. No. This is your original matrix A. Just take away this 2, 3, then substitute the 2, 7. So it will go 3, 4, then what? 2, 7. So I have 3, 4, then 2, 7. So this one will be what? Your matrix AY. Then you find for the determinants of the matrix AY. So the determinant 3, 4, 2, 7. So now, how do we go about this? We subtract the first diagonal. We multiply the first diagonal, which is what? 3 times 7. Then we subtract what? The second diagonal. Multiplication of the second diagonal. Then we subtract from what? The multiplication of the first diagonal. So I have 4 times 2. So now here, I have the determinant of AY must be equal to 3, 7, 21. Then 4 times 2, we have 8. So now 21 minus 8, which gives what? 13. Positive 13. So we have positive 13. So kindly watch it carefully. Alright, so we can proceed. Please do all to subscribe to this channel. Massa tutorials made easy. Massa tutorials made easy. Alright, so let's continue. Now, if you want to find for the x value, we said that what? It must be equal to what? The determinant of ax all on what? The determinant of a. Then if you want to find for the y value, we said that what? Is the determinant of ay all on what? The determinant of what? A. So now, here, we know our determinant of a, which is what? 1. Then now, what's our determinant of ax, which is what? Negative 8. Then the determinant of ay, which is what? Positive what? 13. So now here, we can proceed, then we can find for our values here. Alright, so now, so x value must be equal to what? The determinant of ax. The determinant of ax, which is what? Negative 8. Then all on what? The determinant of a, which gives us what? It gave us what? We obtained 1. Then now, the determinant, the y value says what? The determinant of ay, which is what? Positive 13, then divided by the determinant of a, which is 1. So we can say that, so therefore, we know our x, which is what? Negative 8, then our y, which is what? Positive 13. So what will be the coordinates of the point of intersection? So therefore, the coordinates of the point of intersection is what? Negative 8, what? 13. Negative 8, 13. Negative 8, 13. Which is very, very simple. So kindly watch it carefully. Alright, so now let's solve for our last example. Our last example here. Let's solve for our last example. So find the point of intersection of the lines. We have 4x minus 2y equals 9 and 8x minus y equals 2. Now, sorry, we didn't verify using the calculator. So let's verify using the calculator. So we have 3, 2, 2, then 4, 3, 7. So negative 8, 13. So that's correct. Alright, so now let's go. Find the point of intersection of the lines 4x minus 2y equals 9 and 8x minus y equals what? 2. So how best can we solve for that? So that's our last example. So kindly watch it carefully. Now, we can solve this still using the matrix, but this time around we are done with the Cramer's rule. We can go by what? The inverse approach. So using the matrix method. So using the matrix inverse approach. So using the matrix inverse approach. So how best can we use the matrix inverse approach to solve this? First of all, let's deduce our matrix. So we have 4x minus 2y equals 9, which is equation 1. Then 8x minus y equals 2, which is equation 2. So we are deducing the matrix. Then we can say that I have 4, 8, negative 2, negative 1. Then we have what? 9, 2. So my xy, I've forgotten my xy, which must be equal to 9, 2. So 4, 8, negative 2, negative 1, which is multiplying xy, which must be equated to what? 9, 2. So now we want to find for the what? Using the matrix inverse approach, we want to find for x and y what? Value. So now we can say that let our a be what? That. Then which is multiplying, this is our b, which must be equal to what? Our c. Now we are finding for xy. And this xy, this matrix is what? Matrix B. So with this, we have A times B equals what? C. So we have to find for this matrix what? B. This matrix B is what? XY. And if you want to find for XY, then you have to find for what? This matrix B, and this matrix B is the same thing as what? XY. So now we have to do our change of subjects here. Watch here, A times B equals C. We want to make B the subject. Then you have to divide both sides by what? A. So I have A times B all on A equals what? C on what? A. So this one cancels. Then I have B must be equal to what? C on what? A. Right. So B must be equal to what? C on A. Now, this can be written as what? B, which is equal to, we can write this C on A as what? 1 on A. Right. 1 on A times C. We can write this one in the form 1 on A times C. And we know that it's the same thing as what? Multiplying what? Multiplication of fractions. Multiplying fractions. So now, when you want to multiply fraction, we multiply the numerators, then we multiply what? The denominators. So 1 times C, we obtain what? C. Then A times 1, we obtain what? A. So it's the same thing as C on A. Now, this 1 on A can be written as what? Indices. So it can be written as what? A to the power what? -1. Right, A to the power -1, then times what? C, then times C, then times C. How did we get A to the power -1? Watch here. 1 on A. This 1, I can write it as a base of A. This A, what's the exponent? It is 1, right? Now, this 1, I can write it as a base of what? A. So let's assume that that A is a number. So if we assume that, then I can write this one as a base of A, which is A to the power what? 0. A to the power 0, we are assuming that A is a value. So if A is a value, then A to the power 0 is what? 1, right? So now, all on what? A to the power what? 1, right? So now here, if they have the same base and they are dividing, we can still write it as what? A to the power 0 divided by what? A to the power what? 1, right? They have the same base and they are dividing. And from the laws of indices, A to the power m divided by A to the power n. Now, if they have the same base, it will go A to the power m minus n. A to the power m minus n. So the same thing applies here. A to the power 0 divided by A to the power 1. So we have to subtract A to the power 0 minus 1. And 0 minus 1, which gives the same thing as what? A to the power -1, which is the same thing there, right? Which is very simple as that. Alright, so now let's proceed. So it means if you are finding for the value of B, you have to find for what? The inverse of this matrix A. Then when you are done finding for the inverse of that matrix A, you multiply by what? C, the matrix C, which is what? 9, 2, which is a 2 by 1 matrix. So now let's see. So now I want to find for the inverse. So now B is equal to A inverse times C. A inverse times C. So now how can we find for this A inverse? Now, an A inverse, we know that A inverse or A to the power -1 is equal to, if you want to find for the matrix inverse, it is 1 all on what? 1 on the determinant of A. 1 divided by what? The determinant of A times the ADJ, which is what? The adjoint. The adjoint times the adjoint of what? A. Times the adjoint of what? A. So we'll do that. So now let's find for the determinant of A. The determinant of A. The determinant of A. The determinant of A must be equal to what? We know how to find for the determinant. The first diagonal, we multiply that, right? So I have this 4, 8, and then -2, -1. So that's 4, 8, -2, -1. So now how do we find for the determinant of A? We multiply what? The first diagonal, which is what? 4 times -1. Then we subtract minus what? the second diagonal, multiplication, a times negative 2. So we have the determinant of a must be equal to negative 4 minus what? Negative what? 16, right? A times negative 2, we obtain what? Negative 16. So the determinant of a must be equal to what? Negative 4 minus what? So negative times negative, we obtain what? Plus. So plus what? 16. So negative 4 plus 16. So the determinant of a must be equal to, now this negative 4 means we are owing, so it is reducing this having. We are having 16, so it is reducing that. So if it is reducing that, then we obtain what? Positive what? 12. Positive 12. So negative 4 plus 16, which is what? Positive 12. So that's the determinant of the matrix A. The determinant of the matrix A. Now, how do we find for the adjoint of A? If you want to find for the adjoint of A, the adjoint of A, the adjoint or the ADJ of A. Now, the ADJ of A is, this is our first diagonal, right? So our first diagonal, we interchange that. So in place of 4, we substitute negative 1. Then in place of negative 1, we substitute what? 4. So we have negative 1, 4, right? Then now the second diagonal, we do not interchange. We do not interchange the second diagonal, but rather we negate them. Don't interchange the second diagonal. Interchange the first diagonal, but the second diagonal we don't interchange. So now here, we negate what? The second diagonal. So now we negate this guy. So negative, negative 2, we obtain what? Positive 2. Then now negative positive 8, we obtain what? Negative 8. So now this will be what? Our ADJ, that's our adjoint of A, which is in a column 4, we have negative 1, negative 8, then 2, 4. Or in a row form, we have negative 1, 2, negative 8, 4. So that will be our adjoint of A. Now, we now have our adjoint of A, then we have our determinant of A. Then, let's substitute into our A inverse formula. So, A inverse equals 1 on the determinant of A, which is 12. 1 on 12 times the adjoint of A, which we obtain what? Negative 1, negative 8, then 2, 4. So now here, we have to multiply. This 1 on 12 is a scalar or number. And this scalar is a fraction, right? So that's a proper fraction here. So 1 on 12, you have to multiply by the matrix. Now, if you want to multiply a scalar by a matrix, multiply each entries or each element or each members or each object in a matrix by what? The scalar or number here. So we have A inverse, which must be equal to what? 1 on 12 times negative 1, then 1 on 12 times negative 8, then here we have 1 on 12 times 2, then we have 1 on 12 times 4. So this will be what I said. So 1 on 12 times each entries, negative 1, negative 2, negative 8, then what? 4. So now A inverse must be equal to, now 1 on 12 times negative 1, we produce what? Negative 1 on 12. Then now we can reduce this guy. 2 can go here 4, then 2 can go here 6, right? Or we can better still use 4. 4 going to A 2 times, then into 12 3 times, right? So we have 1 on 3 times negative 2, which will produce what? Negative 2 on 3. Negative 2 on 3. Then now, 2 here into itself, 1 into 12, 6. So we will get what? 1 on 6, right? Then now, 1 on 12 times 4. Now, 4 into itself, 1 then into 12, 3. So we have what? 1 on 3. So this will be what? Our A inverse matrix. The inverse matrix. A inverse matrix is what? Negative 1 on 12, negative 2 on 3, 1 on 6, then 1 on 3. So kindly watch it carefully. Alright, so we are proceeding. Then if you are proceeding, I can clean this place, right? Let me rub this place. So now, our formula says what? If you want to find for the matrix B, then it must be equal to what? A inverse, which is this guy, times the matrix C, which is that. This is our matrix C. So now, B must be equal to A inverse negative 1 on 12, negative 2 on 3, 1 on 6, 1 on 3, then times C, which is 9, 2. 9, 2. So let's see how we can multiply that. So now we have what? A 2 by 2 matrix, 2 by 2 matrix, multiplying what? A 2 by 1 matrix. Now, watch here. If you have 2 by 2 matrix multiplying a 2 by 1 matrix, let's see. Their inside elements are what? The same. Then what will be our result? We will get what? A 2 by 1 what? Matrix. The inside elements, which is 2, 2, they are the same. So they cancel out here. So what will be our result? A 2 by 1 what? Matrix. A 2 by 1 matrix. So we obtain what? A 2 by 1 matrix. So if you are multiplying, then your results, you obtain the result to be what? 2 by 3 matrix. Then make sure that you are wrong, because we are getting a 2 by 1 matrix. So now let's see how we can multiply that. Now this negative 1 on 12 will multiply what? 9. Negative 1 on 12 multiplies what? 9. Don't use this guy to multiply that guy again. Negative 1 on 12 will multiply 9. Then 1 on 6, 1/6 will multiply this 2 whole number. Then you are done. You come down. Negative 2 on 3 will multiply 9. Then 1 on 3 will multiply what? 2. So now watch here. We add, so don't forget. So we have that negative 1 on 12 times 9, right? Then plus, right? 1 on 6 times 2. Then we have what? We come down because they are down, below. So negative 2 on 3 times 9, then plus 1 on 3 times what? 2. So we have this. We have this. So I can rub this place. So now let's see. We have matrix B, which is equal to 3 can go here 3 times, then into 12 4 times, right? 3, 3, 9, 3, 4, 12. So I have negative 3 on 4. Negative 3 on 4. Then plus 2 can go here 1 into 6 3 times, right? So I have 1 on 3 here. 1 on 3. Then now here, 3 will go here 3 times. 3 will go into itself 1, then 2 go into 9 3 times. So I have negative 2. So we have negative 2 on 1 is the same thing as negative 2. Then times what? 3. Which is, I can proceed and say that negative 2 times 3 gives us negative 6. Then plus. Now 1 on 3 times 2, which is what? 2 on 3. So now matrix B must be equal to, then now let's see, negative 3 on 4, then plus 1 on 3. Let's move fast, which I'll get to negative 5 on 12. Then now here, negative 6 plus 2 on 3, which will get to negative 16 on 3. Negative 16 on 3. So now let's testify using calculator. For negative 2, then 9, then 8 minus 1, then 2. Negative 5 on 12, then negative 16 on 3, which is correct. So now this matrix B must be equal to, we know that the matrix B is this guy, xy. So xy. Then now we know that equality of matrix. Now, equality of matrix or equal matrix or matrix equality. We equate the first entries. Now let's talk of this diagonal. Sorry, this row. The first row here. Then the second row. We equate them. So now then we can say that x equals negative 5 on 12. Then we have y being equal to negative 16 on 3. So now what will be the point of intersection of these two lines. So therefore, the point of intersection of these two lines, is what? Negative 5 on 12, comma what? Negative 16 on 3. So this brings us to the end of what? This topic. The beloved topic, point of intersection of two lines. Point of intersection of two lines. Mind you, you can get 3 lines, then they can tell you to find for their point of intersection. 3 lines too can meet at a particular point. The same approach, you have to what? Solve it what? Simultaneously. If you use the matrix method, then you get a 3 by 3 matrix and know how to find for that. So don't worry. Kindly go through the steps, watch the video, sit down on your buttons and watch it carefully. Alright, thank you for subscribing to Massa Tutorials. Have a nice day. Bye bye.